Paul Dirac was one of the most important scientists of the 20th century. He is known for his work in quantum mechanics and for developing the theory of antimatter. His ideas changed the way scientists understand the physical world. Dirac was a brilliant mathematician and physicist who made important discoveries that continue to influence physics today. Dirac was born in England in 1902. He was a quiet and serious student. From an early age, he loved mathematics. His father, a teacher, encouraged him to study hard and always do his best. He attended the University of Bristol, where he studied electrical engineering. But his interest soon shifted to physics, and he decided to focus on this subject instead. After finishing his studies at Bristol, Dirac went to Cambridge University to continue his education. There, he became known for his deep understanding of mathematics and physics. He worked with other famous scientists, including Niels Bohr and Werner Heisenberg. At Cambridge, Dirac began to explore the mysteries of quantum mechanics, a new field of physics that was still developing. Quantum mechanics was a theory that tried to explain the strange behavior of very small particles like electrons. Before quantum mechanics, scientists thought that objects, like planets, moved in a predictable way. But when scientists studied tiny particles, they found that these particles didn't follow the same rules. Instead, they behaved in strange and unpredictable ways. Quantum mechanics was created to explain these unusual behaviors. Dirac made many important contributions to quantum mechanics. One of his most famous ideas was the Dirac equation. This equation described how particles, such as electrons, behave when they move at very high speeds. It combined the ideas of quantum mechanics with the theory of relativity, which was developed by Albert Einstein. Einstein's theory of relativity describes how objects move at very high speeds, close to the speed of light. Dirac showed that the two theories could work together. This was a groundbreaking discovery and helped to shape modern physics. The Dirac equation was important because it predicted the existence of antimatter. Antimatter is a type of matter that is the opposite of normal matter. For example, the antimatter version of an electron is called a positron. A positron has the same mass as an electron, but it has a positive charge, while an electron has a negative charge. The discovery of antimatter was a huge breakthrough in science. In 1932, scientists at the University of California discovered the positron, confirming Dirac's prediction. This discovery proved that Dirac's work was correct and that antimatter exists. Another important contribution Dirac made was to the field of quantum electrodynamics (QED). Quantum electrodynamics is the theory that explains how light and matter interact. This theory is a part of quantum mechanics, but it focuses specifically on the relationship between particles of light, called photons, and matter. Dirac's work in QED helped scientists understand how particles exchange energy and interact with each other. His work laid the foundation for much of the research in particle physics that came later. Dirac's ability to connect different areas of physics was remarkable. He had a special gift for finding elegant solutions to complex problems. He was known for his clear and simple approach to solving difficult questions. His ideas were often groundbreaking and helped shape the future of physics. Despite his many successes, Dirac was a quiet and reserved person. He did not enjoy public attention and often preferred to work alone. He was not interested in the social aspects of science and did not give many public talks. But his scientific work spoke for itself, and he became one of the most respected scientists of his time. In 1933, Dirac was awarded the Nobel Prize in Physics for his work on quantum mechanics. The Nobel Prize is one of the highest honors a scientist can receive. Dirac's award recognized his important contributions to our understanding of the behavior of particles. His work changed the way scientists thought about the fundamental nature of matter and energy. Dirac's research had a big impact on many areas of physics. His ideas helped lead to the development of quantum field theory, which describes the behavior of particles in terms of fields rather than just individual particles. Quantum field theory has become one of the most important frameworks in modern physics. It has helped scientists understand the behavior of particles in high-energy environments, like those found in particle accelerators. Another important area of Dirac's work was his research on the theory of magnetic monopoles. A magnetic monopole is a theoretical particle that has only one magnetic pole, either a north or a south pole, instead of the usual two. While magnetic monopoles have not yet been discovered in nature, Dirac's work on them has influenced many scientists in their search for these particles. His ideas about magnetic monopoles are still studied today in modern physics. Dirac's work also had a lasting influence on the development of technology. The understanding of quantum mechanics and antimatter has led to important inventions in fields like electronics and medical imaging. For example, the development of the positron emission tomography (PET) scan in medicine relies on the principles of antimatter that Dirac predicted. His ideas have helped shape the technology that we use in everyday life, from computers to medical devices. Throughout his career, Dirac received many awards and honors for his work. He was a professor at the University of Cambridge for many years, where he mentored many young scientists. His students went on to make their own important discoveries, continuing his legacy in the world of physics. Dirac was also a member of the Royal Society, a prestigious group of scientists, and he received many other honors from scientific organizations around the world. Dirac's work had a profound effect on the way scientists understand the universe. His ability to think deeply about the most difficult problems in physics made him one of the greatest scientists of his time. His discoveries helped lay the foundation for many of the advances in physics that followed. He is remembered today as one of the pioneers of modern physics. Even though Dirac passed away in 1984, his work continues to inspire scientists around the world. His ideas about quantum mechanics, antimatter, and quantum electrodynamics are still taught in universities and used in research today. His contributions to physics changed our understanding of the universe and will continue to shape the future of science. Paul Dirac was a brilliant scientist whose work has had a lasting impact on the world. His discoveries have influenced many areas of physics and technology. He was a quiet and humble person, but his ideas were groundbreaking and changed the way we understand the universe. Dirac's legacy continues to inspire new generations of scientists, and his work will remain an important part of the history of physics.